the James Webb Space Telescope has found evidence that the cosmos has ceased expanding, which is surprising news. A significant tipping point is occurring in the space sector. Is it possible that we are approaching a big rip or big freeze, in which the entire universe abruptly freezes or tears apart, and that the cosmos will soon come to a complete halt? Scientists from all across the world are concerned and investigating how these new findings may affect our existing cosmological models. Now, we need to ask ourselves basic questions concerning the nature of time and space. The concept of cosmic expansion will shortly celebrate its 100th birthday. An astronomer named Edwin Hubble was studying the recently found galaxies in the 1920s in the United States. Imagine the moment when scientists discovered that the Milky Way was only one galaxy among many and not the entire cosmos. Hubble was among the first individuals on this planet to understand the size of the cosmos when the Andromeda Nebula first appeared, and then more and more galaxies began to open up before his sight. In addition to this astonishment, Hubble also witnessed something that further shocked him. The galaxies that were far from us in particular appeared to be drifting away from us. What explanation is there for this? Hubble used the redshift of light to calculate the distances and motions of the galaxies. The light's color spectrum shifts further to the reddish the farther the light source is from the observer. Hubble measured the motion of galaxies and calculated their velocities. The Hubble constant is a linear quantity that the researcher discovered while doing this. According to this, galaxies that are farther away from us move away proportionately. In 1929, Hubble presented his revolutionary discovery, which he later paired with the notion of a Belgian physicist and priest who had been studying the just-found galaxies at the same time. In 1927, Georges Lemaitre had already proposed that the cosmos was expanding from a high-temperature, high-density initial condition. Later on, this idea was dubbed the Big Bang theory. The field equations of Albert Einstein's general theory of relativity, which postulated that the cosmos might be dynamic and expand or contract, served as a major foundation for Lemaitre's work. Lemaitre's theory and Einstein's equations of relativity, along with Hubble's discovery, served as the cornerstones of our cosmology. Before the James Webb Space Telescope joined the scientific arena, not much had altered in these underpinnings in over a century. We are currently witnessing a number of events with this groundbreaking new telescope that are incompatible with the accepted theories of mainstream cosmology. Although it is widely acknowledged that Webb's discoveries have caused a massive crisis in physics, it is less well understood that these issues and difficulties are not new. In actuality, scientists have long found that the universe does not behave exactly as calculations would have indicated. They have even found that, for some reason, the cosmos has ceased growing, at least in terms of our outdated conceptions of physics. Is the cosmos a whirlpool? There is a lot of news, turmoil, and discussion among perplexed scientists at this fascinating time. The question of dark matter and dark energy is one of the most significant issues in evaluating the state of our universe today. The observable gravitational effects cannot be adequately explained by the visible stuff in the universe, according to observations of the cosmic microwave background radiation and the rotation curves of galaxies. Dark matter, an unseen material that accounts for around 27% of the universe's total matter energy density, was the result of this. However, what if our calculations of the universe's dynamics were entirely incorrect? Webb's findings show that we have thus far fully miscalculated basic features of the universe, which may begin with galaxy rotation and undoubtedly extend beyond the universe's expansion. The presence of dark matter and energy would also not be required in areas where these phenomena do not manifest. When scientists learned that the universe is expanding faster in the late 1990s, another serious issue arose. This finding supported the theory of dark energy, which is thought to be the force behind the expansion and may be in charge of the variations in the constants. Once more, we might have made a grave error. There might not be a linear expansion or a space in which the cosmos is expanding, as proposed by Hubble and Lemaitre, if our earlier techniques were incorrect or predicated on wholly erroneous assumptions. According to certain calculations, our cosmos may actually resemble a massive swirl that is fueled by a variety of sources. Consider how various sources of energy and matter's building blocks are directed into this area. Similar to a whirlpool with widely spaced jets, this would result in more turbulence in some areas and smoother dynamics in others. At that point, the notion of the universe's expansion would vanish. Rather, scientists would be forced to acknowledge that their findings are based on flawed observations. Due to the lack of additional important evidence, this explanation of the universe is not currently recognized. But new findings from the James Webb Space Telescope are challenging these presumptions once more, and scientists are gradually being forced to confront uncomfortable realities. Is the Big Crunch, the Big Freeze, or the Big Rip imminent? It seems unsettling since scientists have concluded that an expanding cosmos must eventually come to a horrific conclusion. The Big Rip is a theoretical consideration of where the universe's expansion will go. Let's say the cosmos continues to expand until it becomes fragile and cracks. Sadly, the Big Crunch is not a much more hopeful version because the cosmos will eventually run out of energy and implode. If this theory is correct, the expansion eventually halts, reverses, and the universe's grandeur falls apart. Let's also think about the Big Freeze, in which the cosmos is frozen in a state akin to shock after having expended all of its energy. There is a sort of collapse or shock state in each of these situations, and the expansion ceases suddenly. It's frightening because scientists have found areas of the universe that suggest the expansion is about to stop. Are we about to see the end of the universe? The most recent findings imply that the early universe's structure was far more intricate than previously believed, and that local expansion rates might be influenced by unidentified physical processes. Our comprehension of cosmic concepts may undergo significant modifications as a result of this. Ideas like a cosmos that is everlasting and nourished by multiple sources are regaining traction, and the notions of dark energy and dark matter may need to be entirely rewritten. The physicist Alan Guth, who first put forth the notion of cosmic inflation in the early 1980s, is credited with creating the concept of perpetual inflation. André Linde later expanded on this notion by introducing the idea of everlasting inflation. According to the cosmic inflation theory, in the initial moments following the Big Bang, the cosmos experienced a period of exponentially fast expansion. By demonstrating that in an inflationary universe, some regions can continue to grow exponentially while other regions stop inflating and expand normally, Linde expanded on this hypothesis. The idea of a multiverse is thus raised, where new bubble universes are continuously being formed, each of which might have unique physical characteristics. According to Linde's model of perpetual inflation, the universe has no beginning or end. Rather, the bubble-forming process never stops, suggesting that there is an eternal multiverse. Is the cosmos now truly at a standstill? Our universe has essentially come to a halt, which may sound odd, but it's true. Without a doubt, the growth as we knew it, or believed we understood it, has temporarily stalled. Since they were only ideas in our minds or hypotheses on paper, all of the dynamics in the universe are currently at a halt. Our research is currently frozen and at a standstill due to a shockwave known as the Big Freeze. The space industry and research are in a condition of uncertainty as a result of Webb's measurements and photos. Every picture that depicts the young universe or makes reference to massive structures challenges the conventional wisdom. The stream of fresh discoveries keeps coming. Webb keeps producing new measurements, and yet another image that doesn't match the full picture of the universe as scientists have depicted it for nearly a century. According to the Big Crunch concept, this image is currently disintegrating. The question of whether all these ideas are fundamentally incorrect and whether we might be living in a universe that is far more dynamic and variable than we previously believed is more relevant today than ever. Researchers have been building hypotheses on flimsy foundations and building a house of cards for a long time. The foundation of nearly our whole cosmology is dark matter and dark energy, which were ultimately impossible to verify. Other methods, like the hypothesis of the variable speed of light, the MOND theory, the theory of holographic gravity, or the concept of weary light, demonstrate that the world can also be explained using entirely different parameters. Fritz Zwicky, who was Swiss in the 1920s, is credited for coining the concept of fatigue light. According to his theory, light from far-off galaxies seems redshifted because it loses energy over long distances. This theory offered a different explanation for the universe's expansion. The variable speed of light theory, which postulates that the physical characteristics of light would have been different billions of years ago than they are now, is quite similar. Our entire cosmic viewpoint is incorrect if this is the case. In essence, the MOND theory makes a similar assumption. Modified Newtonian dynamics imply that gravity is not a constant quantity either, but has changed throughout time. What's even more intriguing is holographic gravity. This is due to Eric Verlinde's theory, which suggests that gravity is a product of the fundamental laws of thermodynamics and quantum information rather than a fundamental force. To put it simply, this would imply that our world operates like a gigantic hologram, with us potentially co-creating the physical quantities that we are able to see. It's possible that we are the ones causing the issues that our natural science is now dealing with if we integrate quantum physics with the material reality. Sign up as a subscriber right now to participate in each new video.